Hello, welcome to this video. This is going to be on the OEISorg website, which is the online encyclopedia of integer sequences. And we're going to be talking about how you use this to assist in your compositional process, to generate musical ideas, or just to create music in general. Basically, this is a website that was created by the mathematician Neil Sloan, and he still maintains it, along with a community of other sequence fiends. Like many mathematicians, Neil is very lovable, and you can find videos of him talking about various integer sequences on YouTube. Like he's on Numberphile and channels like that. Totally worth checking out. I feel like this is a really cool tool that I didn't quite understand when I first came across it, and as I get more and more math under my belt, I feel like I can appreciate it a little bit more, and I know how to utilize it better. So I want to get into how to utilize it for creating music. So without further ado, let's get into it. So first of all, what you're going to do is navigate over to oeis.org. There we are. All right, and so you can see that it gives us this little sequence here, and there's a search function. You can search for your sequence or type in a sequence. So if we say, what is 1, 1, 2, 3, 5, 8, we all know what this one is. Okay, so Fibonacci numbers, f of n equals f of n minus 1, etc., etc. Cool, and so then it's indexed as A000045. Cool, and so then we can graph this, and doesn't look that interesting. We get this little curve here, and we get this scatter plot here. But if you go down to the bottom and go to the browse function, then basically it will every 20 seconds just give you a new sequence to fiddle with. And it does it with your camera for some reason. So you can stop the camera if you want and just refresh as needed. Otherwise, it'll keep on refreshing it. So like right now, there's number of transitive relations on n unlabeled points. Cool. Next one. Mersenne exponents. Cool. So I want to see what this one looks like. And, we're again talking about music, but it's, I think, very helpful to get a sense by graphing it first to see sort of what the texture of it is. So we'll graph it. Okay, this is a little bit more interesting. And the logarithmic scatter plot has this kind of, weird quality to it. It's a little janky looking. And basically, no matter, like, even with a totally straight or like almost totally straight line here, once we put it into MIDI form and put some parameters on it, it really can't help but sort of get rid of that, just straight ramping upness. But this one, it's already kind of interesting. There's some little intervallic jumps here. Let's look at a few more though. Okay, number of partitions of a set of n elements where the partitions are of size over 3. Okay, and so we plot it. We got a little curve there. So you could just do this all day. And there's also the list function, the table function, and you'll see that you can listen to it. I personally like to sort through the graphs to see what sort of catches my eye. Like this looks interesting. This scatter plot is kind of crazy, right? So I'm just going to take a screenshot of this for reference. All right, and I'll just go to the sequence there so it's not refreshing. Okay, so triangle T of nk read by rows giving number of fixed 4xk polyominoes of n cells, n cells, n over n is more than or equal to 4, and k is between 1 and n minus 3. Okay. And then the index here, again, is A059680. And so this indexing is kind of useful because it helps, you be able to reference it later. So if you forget what something is, you can just check back here. So since we have the graph now, I'm going to go to the listen function. Right, and so now we get this little interface here. I'm going to sort of start at the bottom, sequence cutoff. So basically, we don't want 4,000 components to it because that's a lot, and it will just go on mostly endlessly. So I'm going to just say 30. I think that's a reasonable number of components that come out of it. All right, and we got instruments here, kind of all the typical MIDI instruments. I'm just gonna be boring and go with a clean guitar, electric guitar. I personally don't really mess with the attack velocity or the release velocity, and the rate, you can definitely mess with, but I tend to not mess with it and just export the MIDI and then deal with it after that. Because, it doesn't really matter how fast it's going. You're looking more for the pitches and the intervals here and sort of like the shape of it. So what I do mess with is the pitch modulus. And so with modulus, basically, if you say, basically the modulus would be 12, then it would do divided by 12 and then the remainder. And so this helps because it won't go outside of the range of 12. So if we want to keep it within an octave, we can. So I'm going to save a few of these. First of all, let's try it within the octave. And, MIDI notes go between 0 and 128. And I personally, just with my guitar, I like to do 35 because that means the lowest note will be a low B. If you wanted a low C, you could do 36, but I want that low B in there. And so then you can do the duration modulus. I'm going to keep it at 1 on this one. And basically, if you keep it at 1, that means that every note will be the same length. If you do a different modulus, then it will have a little bit more angularity to it. And you can also do a duration offset. And so that sort of lengthens your bass unit that it generates. So anyway, let's see here. Yeah, let's save this one. I go to save instead of play. If you do play, then it will save it just named play, and it's very helpful to have the index in there already. So I'm going to just mention that this is mod 12 plus 35, and I'm going to save it. And now I'm not sure if this is the case with everybody else's methods of playing MIDI files, but for me, I have to rename it so that the file extension is .mid, right? And so let's drop this into VLC. Cool. So this sounds ripe for some metal. Let's see. So maybe let's generate a few more. So now I'm going to say, let's say 19. So this is for the pitch modulus. That means that you have an octave plus a perfect fifth. So kind of the range on the guitar will be my low B to my, I guess, high F sharp. Or not that high F sharp, but it's like, an octave plus 7 semitones. And yeah, we'll keep the modulus the same for the duration and the pitch offset the same. So we'll save it again. Mod 19 plus 35. All right, and again, we'll rename this file. So it's .mid. And let's drop it into VLC, hear what it sounds like. Cool, and let's do another one at mod 24. And change the extension. All right, so basically you're just changing the range each time. Let's do one more where we have a much wider range. So we'll say 80, we'll say 60. That's crazy enough already. Actually, let's extend it to so that we can hear more. We'll just say 100 components. All right, save. Mod 60 plus 35, 100. change the extension again, drop into VLC. Beautiful, right? All right, so now that we have these, let's drop some of these into like a notation program. So let's start with this this octave one. All right, so here we are now. Of course, it's saying that's out of range because I'm assuming a 7-string guitar, but we can change this tuning. All right, so now we have this, and I'm just going to correct this so that it fits nicely. Cool. So now we basically have a riff, and I'm going to export this as a PNG. All right, and let's try another one in here. Let's try the 19 one. Now you might do this on Sibelius or Finale or whatever you use. I find that while I have Sibelius and, you know, it's for all those very mature notation readers, which sure, I can read notation, but this, even though this is kind of dorky with all the tabs, you know, it tends to work better. So I enjoy Guitar Pro, and it's a fraction of the price that Sibelius is. So, okay, I'm going to switch that again. Cool. So now we have this version. Export that as a PNG. All right. Now, this is pretty cool already as far as I'm concerned, that you can just have a riff generated like this pretty much. But let's look at the website, the encyclopedia, again a little bit more. So basically, you can change the tempo here and the volume, and you can do any different integer sequence. You can also change the durational modulus, though. So let's see what it sounds like with a modulus of 5. And I'll save it here. Boom. You know the routine now. Change that extension to a .mid. All right, say mod or rhythmic mod 5. All right, so let's drop that into VLC. All right, so that's going to go on for another 40 seconds or so, so I'm going to just stop it. You can see that it's already, I mean, it sounds like some sort of modern, wacky stuff. So another thing that I would mention is, like, let's say that you set the pitch modulus to 1, and the, let's see here, we'll shorten it back down. So with the pitch modulus at 1, it's only going to play one note. In this case, it would be the B, the 35 of 0 to 128, which is a B. And I'll change the rhythmic or the durational modulus to 3, or let's say 4. I feel like it might get a little bit more angularity. We'll save again. You know the drill. mod 1, rhythmic mod 4. Cool, save. So as you can see, we already have a ton of MIDI files generated, and it's kind of important to keep them well labeled, because otherwise you're just going to be like, what's this one? So drop that into VLC. Let's see what it sounds like. All right, so that just gave us a rhythm, basically. So that could be good for generating drums or whatever you're thinking. So I'm gonna drop it back into Guitar Pro. Where did you go, file? Is this it? Yes, cool. So here we are again. Gotta change it to 7 string so it doesn't have these red notes. All right, and I will make this look a little bit prettier. All right, cool. So now, I mean, you got a rhythm, and this is noted kind of in a not particularly pretty way, but apply whatever tools you want to it. Let's see here. Yeah. Anyway, that gives you a rhythm. So you could also similarly just drop that MIDI file into something like, whatever sequencer or DAW you're using, and use that as some rhythmic source material. And, this, I guess, gets into the question of, are we, actually composing anything here? Is there anything wrong with using this to generate your music? Like, is there something special about coming up with something that has just like the natural structure that you came to? Like, this seems exhaustive to me, and I think that's really cool to have this huge catalog of content. And if you think to somebody like Elliot Carter, or like even Ben Monder as a jazz musician, or some of these people like Miles Okazaki, also jazz guitarist, who's very focused on these rhythmic permutations. There's such a vast amount of material here, and the idea that we wouldn't use it because it's cheating or something like that. I think that there's a little bit of an egotistical thing in composition these days, where you composed this, and it doesn't really respect the fact that there's so much musical content that is out there that just needs to be rendered, really. And so I think this website's super cool. I hope that this is useful for anybody who wants to explore sort of like some basic algorithmic composition. This is going to be a central part of riff generation and like etude generation for my work. So anyway, I thought that I'd share this with you. Hopefully you find it useful. Thanks for watching.